Hello everyone! In the previous video Techniques and Technology, part 1, we started discussing early human techniques and technologies as a purposive activities. We mentioned three major historical periods of developing techniques and technologies. Development of techniques up to 17th century and period of Industrial Revolution. Let's move to the third period from approximately middle 19th century to present days. Progress was definitely speeding up more rapidly. Do you want to remind yourself how technology was moving forward using a few examples? The Great Exhibition of 1851 in London's Hyde Park had a main purpose to display industrial achievements of the world. Before that, there were few national exhibitions in different countries, started from France. But the London's one started a tradition on a world's scale. The exhibits gave some impression of the state of the art in the various technologies, and it offered some idea of the progress made by different nations. This was additional way of distributing technological ideas on a top of patent system and works publishing. There were a lot of significant scientific and technological discoveries and publications, along with practical expansion of technology in the third period of developing techniques and technologies. Let's remind about just few examples. James Prescott Joule realized that the exchange rate between heat energy and mechanical energy must be constant, no matter what processes, no matter what materials are involved. He put energy at the center of physics. Thermodynamics as the new science and technology was called by William Thomson in 1849, introduced an entirely new element into science. Energy is concerned in all the actions of nature and techniques. When we discussed science methods in previous videos, we talked about universities of technology and PhD degree system. It was about German educational system when von Humboldt's universities were supplemented by German state technical colleges, named Polytechnics. They contributed to science a lot, as well as to technology. On the top of that, several other organizations appeared to help technology to flourish even more. Organizations started to appear in Germany, which moved the country to industrial supremacy in Europe that time. Technologists and engineers know that it's important to carefully measure and standardize things they work with. So special metrology and standardization organizations were created. In 1895, the Reichsanstalt Metrology Institute was established in Germany, and it inspired to open similar organizations in other countries. For example, US Bureau of Standards in 1901 and British National Physical Laboratory in 1902. Another type of organizations appeared that time in Germany. They were state and industrial research organizations. Konstanzstelle for explosive research, the Königliche Mechanisch-Technische Versuchsanstalt, the Chemisch-Technische Versuchsanstalt, the laboratories at the Braunbahn and laboratories of the dye-stuffs firms. What else happened? Gottlieb Daimler and Wilhelm Maybach work on manufacturing of heat engines as an alternative to steam engines. In 1883, they built their own engine with a simple carburetor to vaporize the gasoline. 2 years later, in 1885, they made the world's first motorcycle, and the very next year of 1886, their automobile. In 1890, the Daimler Motor Company was established. Peugeot in France were soon building automobiles with Daimler engines. That consequently requires petroleum industry to provide with necessary resource to power such engines. What else? Expansion of electricity moved forward with invention of incandescent bulb. Thomas Alva Edison and Joseph Swan invented it independently over the years of 1878-1880. No more need to fire wood, charcoal, oil to have lights at the night time. British Association Committee of Electrical Units established internationally accepted units of voltage, current, resistance, and energy. Electricity could be sold in rational and well-defined measured units. And the world's first power station selling electricity to the public was opened by Edison in New York in 1882. Werner von Siemens and his brother Karl and Wilhelm contributed a lot to the electrical supply industry in few countries like Germany, England, and Russia. Interesting fact: the more technically advanced communities become and better fast communication in place, the greater the chance of simultaneous inventions to happen. It may now be said to be the rule rather than exception. For example, incandescent bulbs were invented simultaneously and independently by Edison and Swan. Radar invented in several countries. Jet engine came from Britain and Germany. Moving next, the origins of electronic communications. The railroad was the biggest simple factor in the creation of a telegraph network, which is communication using wire lines. In 1873, Graham Bell invented the wired telephone to use and reuse lines for transmitting voice. In 1801, Guglielmo Marconi claimed to have sent messages across the Atlantic using radio waves, long-distance radio transmission. This was an example of wireless information transmission. There were two other candidates for the title of inventor of radio, Walesman Hughes and the Russian Popov, but looks like it was not radio in terms of full cycle of transmitting and receiving radio waves. Hughes misunderstood principle and eventually failed to develop his invention. Popov initially made a receiver to detect radiation from lightning flashes, so he founded meteorology. But he doesn't seem to have invented a transmitter to have communication, which is a goal for a radio. By the 1930s, practically every home in the industrially advanced country had a radio set. In a half a century, public mobile phones will start coming from Scandinavia. Moving next. Airplane industry has a story began from specifications publication for aircraft designed by George Cayley at the beginning of 19th century. Brothers Orville and Wilbur Wright on 17th December 1903 took off biplane with two propellers driven by a 12 horsepower gasoline engine. That was the first airplane flight. In 1909, British instituted a Board of Aeronautics. In 1915, National Advisory Committee on Aeronautics was established in the United States. Traditionally, German universities had concentrated on pure science and has left technology to technical universities. Such divisions between pure science and technology were not always clear, and Göttingen-Gauß's University, one of the leading universities in the world for theoretical physics, established a department of aeronautics. Its student Hans von Ohain designed first jet engine-powered experimental plane for a short flight in August 1939. Frank Whittle invented jet engine as well in Britain. We already mentioned high chances of inventing things simultaneously and independently in technically advanced countries. Like Germans made V2 rocket, which pointed the way to the space travel. Moving next. Atomic power. Nuclear physics was born in 1913 when Niels Bohr, working with Ernst Rutherford, accounted for the orbits of the electrons by using Max Planck's quantum theory. Otto Hahn and Fritz Strassmann paper of January 1931 mentions suggestion by Lise Meitner that uranium nucleus struck by a neutron leads to splitting them into other parts of different atoms with releasing considerable amount of energy. If we have enough atoms for initial reaction, more atomic parts will be emitted, causing cascade of chain reaction. And calculations showed that energy released by a chain reaction would be enormous. In 1956, the first nuclear power station at Calder Hall, Britain, began to provide electric power to public. Moving next. The origins of modern computer. Konrad Zuse made his first purely mechanical computer in 1934. Zuse used binary arithmetics and made possible storing a step-by-step program. Another example is a big machine constructed during years of 1939 and 1944 by IBM, based on Howard Aiken's specifications. Alan Turing constructed few other big machines: Colossus in 1943, Mark II Colossus in 1944. Nowadays, computers became relatively small and very powerful. That's probably enough with examples of modern period of developing techniques and technologies. Just to remind, We divided our history into three periods. The first period of early techniques development, from ancient times up to 17th century and the rise of modern science. The second period is Industrial Revolution and appearance of the term technology. And the third period with a story from mid-19th century to nowadays. Let's wrap up all examples. Examples of the first period are: man became the creator of his tactics of living by inventing of handmade human techniques on the top of biological built-in instincts. Splitting technical process into separate tool making and tool using. Another separation happened with language in place. Technique of pure thinking, planning about activity and actual activity making something. System of learning, apprenticeship. Manufacture of scientific instruments tools by ancient Greeks. Medieval German technicians mainly in mining and metallurgy. Italian techniques of art, architecture and mechanics. European agricultural innovations for enabling fertile soil, rotation of crops and Saxon plough. Invention of mass adult education. Avalanche-like use of techniques with an example of Johann Gutenberg's printing press. Scientific revolution, mid-16th century till almost the end of 17th century mentioned. There were Galileo Galilei's inventions and his metrics of machine performance. Examples of the second period are: coining the wider term technology in the 17th century at a time of Industrial Revolution. Patent system and journalism, which expedited innovation. Scientific study about water steam power brought Newcomen's steam engine. Innovations in textile industry indicated potential of mass production industry, for example in structural engineering, power generation and transmission, machine tools, chemical industry and transport. Then there were relatively cheap cast iron, L-section rails, locomotive and eventually railroad system. Organizing science structure the way we know it today is the first 3 decades of the 19th century. And then early steps of electrotechnology by Michael Faraday starting in 1831. Examples of the third period discussed already in this video are: distributing technological ideas worldwide with great exhibitions starting in 1851 in London. James Prescott Joule come up with energy term. William Thomson brought thermodynamics as new science and technology with energy in all actions of nature and techniques. Educational, metrology and standardization. State and industrial research organizations speeding up technological innovation pace. Heat gas engines, motorcycles, automobiles, petroleum industries appeared and were on a rise. Expansion of electricity with invention of incandescent bulb and electricity consumer, which lead to generating, distributing and selling electricity to public. Electronic communications with telegraph network, Graham Bell's telephone, Guglielmo Marconi's radio. Sophisticated airplane industry with the first flight of Wright brothers. University developments of aeronautics, jet engines and rockets for future space travels. Atomic power from first discoveries to nuclear power stations. And the last example was the origins of modern computer. Let's finish this video with a reminder about few terms and their importance in our human lives. Technique is a procedure, purposeful activity that allows to accomplish a task based on skill or ability in a particular field. We can also say that technique is a skillful, efficient way of doing or achieving something. Technology term came during Industrial Revolution and the era of manufacturing. Usually refers to use of science and industrial tools. Technology includes technical methods and techniques in the first place, as well as skills, procedures, organization, industrial management, tools, raw materials and resources to produce desired products, to solve problems, to fulfill needs. Why discussion about techniques and technologies is so important? They both are about the purposive practical activities. What is amazing about both of them, that purpose of an activity can lead to results achieved more efficient, faster, with less effort and less power, sometimes overcoming existing limitations. It may be personal achievements in sports, for example, when you know proper techniques how to make your boxing punch stronger, based on proper arm movement combined with twisting body and turning legs. So you acting anatomically like a compressed spring, which can lead to better efficiency and more wins on a boxing ring for you. Or you received specific 5 days on the job training, which saved you years of self-learning and allowed you to make your work more efficiently as soon as your training is over. This can be achieved by proper use of effective teaching techniques. Or your company knows how to automate working processes so they can be executed 24 hours a day, 7 days a week without waiting when your team will come to work in the morning. This can be achieved by available proper automation techniques. Or your company knows process how to produce state-of-the-art microprocessors, which work 10 times faster than those from competitors. So you have competitive advantage for a certain amount of time. This is because of know-how, because of rare technology in your company's hands. Sometimes technological research can be possible only to large corporations or even states, because it may require decades of spending without final result, which can bring some companies or even countries on the higher level of technological advance. These are all examples of knowing techniques and technologies which you personally or your company or your country could be definitely ahead of others who don't know or don't use them. Higher efficiency and know-hows are key factors to admire. I'm very motivated to surround myself with effective techniques and technologies. What about you? Both techniques and technology are very important in everyday life and will be widely introduced and discussed in our MotivationHow portal. We will try to aggregate all personal techniques and industrial technologies, to have short videos with answering questions what and why. What this technique or technology is about and why it may be interesting for you or your company. We have just finished our 2 videos, Techniques and Technology. In the next videos, Classifications and Subject, we will discuss how to hierarchically structure information and effectively navigate through all available topics based on such structuring. It would be very helpful for you, doesn't matter are you studying, working, researching, or just want to improve your skills of effective information search. Hope to see you there.